Good afternoon. Today we are going to take a look at the topic of linked lists. So we already linked list is actually a type of linear list. So you have already studied one type of linear list which is very common, which is array. So the elements of an array, they are stored in a contiguous block of memory. That means all the elements are stored in adjacent memory locations. But in case of linked lists, that doesn't happen. In linked lists, there are some nodes, and the nodes are placed at random locations throughout the memory, but they are linked to each other by using pointers. So here you can see that there are 4 nodes, and each node is pointing to the second other node. So the first node, so you can see the structure. Let us see the structure of the node. So a node essentially contains up to a single linked list, a singly linked list. In a singly linked list, a node contains 2 sections. In the first section, there is the data part, where the actual data that we want to store in the linked list, that is placed over here. And in the second part, we store the address of the next element. So you can see the address of the next element is 3600, that is stored over here. Next, in the second node, you can see it is storing the address of the third node. So like this, all the nodes are linked to each other, even though they are not stored in adjacent or contiguous memory locations. And lastly, you can see that there is in the very last node, the pointer part is null because it is not pointing to any element. And the head part, so you can see there is another pointer called the head. So the head pointer is usually used to identify the starting part of the linked list. So in case of arrays, there is an index number. All the elements of an array are identified by Unix index numbers. So the first element of the array is stored at index 0, the next one at index 1, and so on, if we use a 0 based indexing. But in case of our linked lists, that is not the case. So there is no concept of any indexing over here. So in order to identify the first node, we are using a pointer called the head. So the head pointer's job is to point to the first node of the linked list. And once the head is assigned to the first node of the linked list, it will not change. It will stay pointed to the first node throughout the existence of the linked list. As long as the linked list continues to exist in our memory, the head will point to the first node always. Its assignment will not change. Also, there is another pointer called the tail, and in some textbooks it is also referred to as temp. So the tail or the temp pointer is another pointer which is pointing to the last node of the linked list. So this is the basic idea of linked lists. So now we are going to take a look at how we can create a linked list with n number of nodes. So let us see the algorithm. So first of all, we'll input the number of nodes that we require. So the number of nodes should always be bigger than 0. So if it is 0, then there is no point of creating the linked list. Now let us see the steps that are involved in the creation of a linked list. First of all, we'll allocate memory for a new node. So whenever we are creating a linked list, we create a linked list by adding one node at a time. So when we are creating a new node, we have to allocate memory for that. Okay, so memory allocation is done using the malloc command. It is different from arrays because in case of an array, we usually create the entire array in one step. So let us say we want to add 10 elements of the array. We want to add 10 elements inside the array. So at the very beginning, we'll create an array with 10 elements. So we cannot create a linked list like that. We will have to, in case of linked lists, we create one node, then we create the next node, then the next one, and so on, and we link them with each other. Okay, now we are going to allocate the memory for a new node, but if the memory allocation fails, it will show an error message, an exist, and it will exit the program. Now we are going to ask the user to enter the data that he wants to store in the node. Let us say that the node being created, it is known as new node. So inside our newly created node there will be a data part, and we'll assign the data entered by user in the data part. And in the next part means the part where the address of the subsequent element is stored. Initially it is null, because when we are creating a new node it is not actually pointing to anything, so it will be null. Next we are going to assign this node to the linked list. So before assigning a node to a linked list, we'll have to check a few things. We'll have to check whether our head pointer is null or not. So if the head pointer is null, that means it is not pointing to any element. That means the linked list is empty. So if the head pointer is null, then we will make the new node. So we will make the head pointer point to the new node, and the tail pointer will also point to the new node, because the tail is also, the job of the tail pointer is to point to the last node. But if there is just one element in the linked list, that will be the first node as well as the last node. So head and tail will both point to the single node that we are creating that for the first time. But if the head is already assigned to a node, then any node we create afterwards, they will have to be linked to the previous node. So how we do that? We are going to write temp next equals new node. So temp next equals new node means temp is going to point the temp pointer. Let me just show you. So when we are creating a new node, the head is pointing to that, and in the pointer part of that node there is null. So head and temp both are pointing to the first node. So the temp pointer is now pointing to the first node, because this is the only node in the linked list. Now let us say we are creating another node. So let us put some value inside, say it is 15, and now this node, this is stored at memory location 101. So temp pointer, which was pointing to the first node, it is pointing to the address of the first node. So let us say the address of the first node is at 80. So it says for subsequent nodes, temp next is equal to new node. That means we are going to make the next pointer of this node point to the address of the next node. So here, when we want to link another node to this, the null part of the initial node will be updated with the address of the subsequent node that we are trying to add here. So when we are adding another node to the linked list, the null part will be overwritten with the address of the subsequent node. So temp will now point to the address of the new node. So temp next is equal to new node. That means we are making the initial node point to the new node, and there is another step which is really vital. Temp is equal to new node. So now, after adding the second node to the linked list, this is no longer the last node. Last node is this one. So now temp, which was pointing to the first node, it will now be shifted to the last node. Because the temp always points to the last node, it will not point to the first node anymore. As we have added a second node to the linked list, now temp will be shifted from here to here. Okay, now let us take a look at the programming code for this problem. So the programming code will mirror all the steps that we have written for the algorithm. First of all, we'll create a structure with the data part and the pointer part. It will serve as the framework for our linked list. for each node of the linked list. So we are creating a pointer called head, which is initially set to null. Temp pointer is also set to null, and the new node, which will store the memory for the newly created node, it is also null. Now we are asking the user to input the number of nodes. So now it is n. So n number of nodes, it may be 1, 2, 3, whatever. So n should be always 1 or more. We cannot create a linked list with 0 nodes. So it should be 1 or more. So if it is less than 0 or 0, then it will be unacceptable. Now we are creating the linked list. So inside the loop, which is running from 0 to n minus 1, we are going to create each node and we are going to link them to each other. So first of all, we are creating a new node using the malloc command. So malloc command is going to take a block of memory and it will assign that block of memory to our new node. So malloc creates a new node, not a new node, a block of memory, which is of the size of our structure. So the size of the structure is defined by its contents. So it contains the data part and the pointer part. So malloc will create a new node, and which will be the same as the size of the structure, and it will assign the address of the new node to our new node pointer. So it will be assigned to our new node pointer. So the new node will be the new node, the pointer called new node, it will now point to this newly allocated block of memory. So initially this block of memory is empty. The data part and the pointer part is empty. Now we are asking for the data that we have to input inside the node. So let us say I want to add 10. So 10 will be added to the data part. How? By using new node arrow data equals to value. So whatever value the user wants to add to the new node, it will be assigned to the data part. So if I want to assign 10 over here, so it will be added to the data part. And now you can see that in the next part, that means the pointer part, it is null. So as of now it is not pointing to anything, so the pointer part, it is set to null. Okay. Now we are going to assign the head pointer to the linked list. So now in the next step you can see it says if head is equal to null, that means the head is initially set to null, it is not pointing to anything. So we have successfully created our first node. In the first node there is an element 10 and the next part, that means the pointer part, is null. So now we are going to link the head pointer to this first node. Head pointer is pointing to the first node, and the assignment of head pointer is fixed. It will not change throughout the program. It will always point to the first node. Now there is another pointer called the temp pointer, which is going to point to the last node. But when we are creating a linked list with a single node, this is the last node, so our temp pointer is also pointing to this one. Okay, so temp equals to head. Temp is pointing to the same node identified by head. Now let us say we want to add a new node, another node to our linked list. So our first node is already added, we want to add a second node. So we have created a second node over here. So we have put the element 20 over here, and let us say this is stored at the memory location 35. So this new node 20 containing 20 is stored at the memory location 35. So now we have to link it with the previous node. How we will do that? To do that, what we'll do is, if the head is not pointing to any node, that means it is there is at least one element in the linked list. So we will go to the else part, and there we will write temp next equals to new node. So temp next equals new node means the next part of the head of the initial node, we will make it point to the new node. Okay, new node that contains 20. So now it will no longer be null, it will be updated with the address of the second node. So instead of null, in the pointer part, it will store the address of the second node, which will be 35. So when we are writing temp next equals to new node, that means of the previous node, in the pointer part of the previous node, it will be updated with the address of the second node or any subsequent node. So here the second node is 20, containing 20, and it is stored at the memory location 35. So this previous node, which is the first node, it will now point to the second node. So in the address part it will be 35. And now there is another step which is really important. It says temp equals to new node. So temp was initially pointing to the first node because it was the only node in the linked list, but now there are two nodes. One is this one, the second one is the new one containing 20. So the job of the temp pointer is to point to the last node. So as we have already added a second node, now when we are executing this step, temp equals to new node. Now temp will shift from here to here. That means now temp will point to the last node, which contains 20. Okay, so this is the very basic idea. So if I want to add, say, another element 30, if I want to add another node containing 30, same process will be followed. We will make the temp next part of this node point to this node, and then we will shift the temp pointer to point to the third node. Okay, so this is how all the elements are created. And if there are no more nodes after the last node, then the last node's pointer part will stay as null. It will not change. So this is the very basic idea of creating a linked list. In the next video, we will see how we can traverse through a linked list. Thank you, and I'll see you all in my next video.